Okay. Now let me share my screen. Can you see my screen now?
Yes, I can see it.
Yes.
Yeah, like the title is Two-Port Networks. Okay, great. So today we'll be discussing two-port networks. So first of all, what is the two-port networks? So a two-port network is an electrical circuit or network with two separate ports for the input and output. So everybody see the figure on the right side. On the upper figure, that is figure A, it's a linear network and it has two terminals. At one terminals, current I is entering, and at the bottom terminals, current I is leaving. So because it has two terminals, those two terminals constitute one port. So this means the definition of port is it will have two terminals, current entering and current leaving. Now, so far in most of the cases, we dealt with single port or one port network. But you see the bottom figure, it's a linear network as well, but it has four terminals, two terminals on the left side and two terminals on the right side. And therefore, left side there is one port, on the right side there is other port. That's why it is the example of two-port network. So you see on the left side, ion current entering, but at the bottom, ion current leaving. Similarly, on the right side port, I2 current is entering, but I2 current is leaving. So the best example of two-port network, just last class, we were discussing about magnetically coupled circuits and then transformer. Transformer has primary terminals and secondary terminals. So transformer or magnetically coupled circuits are the appropriate example of two-port network. Now, in addition to transformer or magnetically coupled circuits, we have studied some other components like operational amplifier, op-amp. You remembered? Op-amp has also input terminals, output terminals. This means input port and output port. Similarly, in electronics, you might have studied transistor. There is base, emitter, and collector. Those 3 points on a transistor. So transistor also is an example of two-port network. Or it might be any cascading network. All are the example of multi-port or two-port network. So in this class, we will mostly concentrate on two-port networks. And this is very essential and very important. As you know, as I have mentioned, two-port networks are used in communication network, in control systems, in electronic circuits, and in any power systems. That's why this is very important. Now, you all know about the circuit and because you have studied transformer, magnetically coupled circuits, operational amplifier or transistor. So you know the nature of two-port network, but two things are very important. One is called impedance parameters, other one is called admittance parameter. I mean, you see the like bottom figure, which I'm telling as two-port networks. I just wrote linear network and I am just showing the relationship between left side port and right side port, but actually they are related, they are integrated with the help of the impedance parameters and admittance parameters. In other words, they are related through impedance in case of series circuit, or in case of parallel circuit, admittance. So today we will be learning how we can calculate the impedance parameter or admittance parameters in case of a two-port network. So from next slide, so you can see in detail, and this is very interesting. So everybody is fine so far?
Yeah, looks good.
Okay. So, okay, then moving forward, go to the next slide. You see, here I have written determination of impedance parameters. So you see everybody, the top figure, the left side figure A, you see it's a linear network, and I have shown there is a voltage source V on and current ion is entering to the network. On the right side port, there is a voltage source V2 and I2 current is entering. Similarly, in figure B, it's a linear network, but it is represented in terms of current sources instead of voltage source. So as you can see, there is a current source on the left port ion and the corresponding voltage is V1. Similarly, right side there is current source I2 and voltage V2. So uh, in this slide, like we are discussing determination of impedance parameter. When we will be dealing with impedance parameter, we will concentrate on this diagram, I mean diagram A. So next time, I mean in few slides later, when we will be calculating admittance parameter, that time we will be using the diagram B. So now everybody concentrate only diagram A. This means a two-port network with voltage sources. Now, as I told you, it's just like a black box. It's only written linear network. So here there is V1 ion and here there is V2 I2. But how they are related? See, as I told you, they are related through impedance. So therefore, everybody see the generalized equation from here. V1 equal to G11 multiplied by ion. So this means I am writing V1 equal to ion multiplied by G11. There is a impedance that I don't know how much, that we will be calculating. And that is the subject matter for today's class. And then, because it is in the same network, but there is other port, there is other voltage source V2, and then the other current I2 is entering into the same network. That's why that V1 is related in terms of I2 with the help of another impedance, which is G on 2. Similarly, right side voltage V2 equal to G21 multiplied by ion plus G22 I2. So therefore, as you can see, there is G11, that means that is the impedance on the left side. G22 is the impedance on the right side. But there are two terms, G12 and here G21. Those are called like transfer impedance or the mutual impedance that relates both left side and right side. So this is generalized equation. So in the matrix form, you could write like left side V1 and V2, and then as you can see how I have organized it. So I1, I2, and then the remaining, this is the impedance matrix or the G matrix. So briefly, you could say G matrix multiplied by ion into I2. Now you see here I have shown the definition. What does G on stands for? G on is called open circuit input impedance. So I am coming that point on. G on to open circuit transfer impedance from port 1 to port 2 because there is symbol G12, so that's why from port 1 to port 2, and that is the transfer impedance. Similarly, G21 open circuit transfer impedance from port 2 to port 1 and G22 open circuit output impedance. Now the question is why it is telling the open circuit. You see here it looks like the figure A, top figure A is like both sides are closed, but here we are using the terminology open circuit. Now you see like what we want to do. So our main goal is to find out those four impedance parameters, which are like G11, G12, G21, and G22. Now look the right side diagram, first figure A. This is basically that topmost figure, left side figure A with voltage source. But see here, What I have done, I have kept right side port open. This means there is a voltage, but current I2 is 0. And so this means you look those equation of V1 and V2. Now, for example, because right side is open, this means I2 equal to 0. You put I2 equal to 0 in the equation. So if you put I2 0, I2 0 in both equation, so what you are getting? See inside G on equal to V1 over ion. Because you see I2 0, so this term becomes 0. So G on is V1 over ion. Similarly, from next equation, because I2 0, G2 equal to V2 over ion. So this means, as I told you, that your goal is to find out or to calculate those four impedances. So how to calculate G1 and G2? That time you have to keep right side not open. This means you have to make I2 0. Under that condition, you can calculate those two parameters. Similarly, look the bottom figure, figure B. In this case, on right side, there is voltage source. Accordingly, current I2 is entering, but I have kept open the left side port. This means ion current has been 0. So therefore, again, go back to those equation, V1, V2. This time you make ion 0, ion 0. So if you make ion 0, what you would get? You would get G onto equal to V1 over I2. That's why here G onto V1 over I2. And G22 from this equation V2 over I2. So therefore, just this is the concept. We have to remember this equation, V1 equal to G on ion plus G on to I2, and next equation, and this concept that when I will be calculating G on G2 on, I will be keeping right side port open. This means I2 should be 0. Next time when I will be calculating G12 and G22, I will be making left side port open. This means you have to make ion 0. This is just the concept. So now I'll be looking to numerical problems, then it will be clear to you. Uh, Everybody, could you follow me so far?
Yes.
Yep, looks great.
Okay, great. Yeah. So now everybody, based on this concept, see the numerical example in the next slide. So you see, the question is determine the Z parameters. So G parameter means you have to find out those four quantities, G11, G21, G12, and G22 for the following circuit. So you see the circuit, 20 ohm, and then here there is 40 ohm, and then 30 ohm. So you can see there are left side two terminals. This means left side, this is on put. On right side, there are two terminals, and then it is another port. So that's why this is the two port network. Now, how we could calculate the G parameters? So therefore, see the solution in the next slide. Okay. So everybody see, like I have redrawn that diagram. Now, you see, in this case, I have attached source V1 and source V2. So everybody look, first I am calculating G11. So everybody see how to calculate G11. So look at the bottom. I have written down those two equations once again for you. So V1 is G11 ion plus G12 into I2. So what is the equation? G11 is V1 over ion. This means you have to make I2 0. So that's why you see the top diagram. Right, actually I made mistake. Initially I made short circuit, but actually it will be open circuit. That's why you can see like I have pen through it. Basically this is open circuit. So because this is open circuit, that's why I am showing I2 current entering is 0. But there is voltage on the left side. This means left part. So now everybody see G on is V1 over ion. So you don't know the magnitude of ion, and that is unknown. So I have put ion. But everybody see what is V1? V1 will be ion multiplied by the impedance, equivalent impedance of the network. So what is the equivalent impedance of the network? So everybody see, because I have assumed that V2 is open, I mean V2 source is open, consequently no current is flowing to the right side. This means through 30 ohm resistor, zero current is flowing. So you can neglect it. So what is the equivalent impedance? Just 20 plus 60. This means ion current is entering through 20 and 40. No current is flowing through 30. That's why you see on the right side I have written V1 equal to ion multiplied by that 20 plus 40. This means 60. So now I plugged in this V1 value in this equation, G on equation. So ion cancelled. I got 60 ohm. Similarly, G21, so again you look at a bottom equation, V2, G21. So if you assume I2 0, because the right side source is open, so this means G21 is V2 over ion. That I am writing here. G21 is V2 over ion. Again, ion is ion, I don't know. But what is V2? Now everybody see the diagram because this is open circuit. So because this is open and no current is flowing through 30 ohm, so V2 means the voltage across 40 ohm. So that's why, and through 40 ohm that ion current is flowing. So V2 means 40 multiplied by ion. So ion cancelled, you got 40 ohm. That is the value. Everybody is understanding so far?
Yep, makes sense.
Yes. Yeah. Now see that you calculated two parameters, G1 G22. Now we have to find out other two parameters, G22 and G12. So and what is the condition to calculate this? Now see this diagram. Now we have to keep left side port open. This means you have to make V1 open, but this means the ion is 0. But you have to keep right side source present. So this means on the right port, there is voltage source V2 and I2 current is flowing. So under this condition, now G22 is V2 over I2. And again, like how I get G22, that is like we discussed in the previous slides. And again, for your easy understanding, I have written down. So G22 is V2 over I2, assuming that ion 0. So, and that circuit, I have made ion 0 because this is open. Okay, so everybody sees, so I don't know the value of I2. So I2 as it is, I have just put what is V2? Everybody see this circuit. What is V2? V2 is I2 multiplied by the equivalent impedance, whatever the impedance. But here you see no current is flowing through 20 ohm because ion is 0. So you have to neglect it. You don't need to take into account. So therefore the equivalent impedance will be that's 30 plus 40. So that's why V2 is 40 plus 30 multiplied by I2. So therefore I2 cancelled, 40 plus 30 is 70 ohm. That is the result for G22. Now similarly, G12, you are getting it from here, from this first equation, G12 is V1 over I2, assuming ion is 0. So now here what you need V1 and I2. So I2 is I2, but what is V1? So look the diagram. V1 is here. That is the open circuit voltage. But here no current is flowing through 20 ohm. So this means V1 will be 40 multiplied by how much current is flowing through it. So what current is flowing through it? That I2 current is flowing through it because no current is flowing through 20 ohm. So V1 is 40 multiplied by I2. So I2 gets cancelled. Result is 40 ohm. So see one interesting thing that in the above we got G21 value 40 and here we are getting G12 value is 40. This means we define that G21 and G12 transfer impedance from one port to two port or from port 2 to one port. That's why the transfer impedance always will be the same. So that's why you got 40, 40. And then G11 and G2 to have different values. So therefore, you are done. Finally, you could put in the matrix form. It is not needed. It is not essential. I am just showing you. You could put G on value 60, G12 value this 40, G2 on value 40, and then finally G22 value here 70. So everybody understands this one?
Yes, sir.
Yeah. It's I mean pretty easy. Just you have to be a little bit careful. You have to look the series parallel combination, and you have to make sure where current is flowing or when current is not flowing. Just a simple circuit, but you have to be careful in calculation. Otherwise, you will get wrong result. Okay, so moving forward, let's have a look another example of the impedance parameter calculation. You see this network. So everybody see, like I think day before yesterday or yesterday, I sent out an email that I have already uploaded the homework set 5 with a due date of next week, I think April 15. And you would notice there are 5 problems in the homework set 5. Among 5 problems, 3 are from the magnetically coupled circuits, and rest 2 are from this chapter. This means two-port networks. So in the homework, you will see right now, similar to this diagram in this slide, there is a diagram in the homework. I think problem number 4. So therefore, if you just understand now, and then you are ready to solve those 2 problems. So everybody see, what's the problem here? In this case, I am asking, find I1 and I2 in the following network. So you see, in this case, on the left side port, there is a voltage source with magnitude 100 and angle 0 degree, and ion current is flowing. Now, in this case, I have given those impedance parameters like G on 2, G21, and then G22. Those values are given. And on the right side, you see there is a 10 ohm resistor across which voltage is VT and I2 current is entering. Now, in this case, your goal is to find out ion and I2 given those 4 impedance parameters. So now let's have a look of the solutions for this one in the next slide. So again, for you, I have redrawn the network, and I have written down those 2 basic equations, our generalized equation. V1 is G1 on ion plus G12 into I2. And then all values are given. You just plug in those numbers. What is the V1 value? This is the left side source, 100 at an angle of 0. G1 value 40. All were given. Ion, G12 were given. And then I2. So you give equation number 1. Similarly, write down the equation for the right side port. So V2 equal to G21 ion plus G22 I2. And then plug in their values. So what is V2? In this case, V2 appears across 10. So therefore 10 multiplied by I2, but you have to consider with respect to the left side node, because current direction is opposite to ion. That's why I have put a minus sign. So therefore 10 multiplied by I2. So minus 10 I2, that is V2, and then G21 value from the given parameters, this one, and G22 was also given 50 and I2. So this is equation number 2. Now you see you have 2 equations and you have 2 unknown, ion and I2, ion and I2. You just find out. So I just simplified equation 2, you see, J30 ion, and I have moved this 50 I2 in this side. So that makes 50 and 10 minus 60 I2. From here I got ion value J2 I2. And I substituted ion value into equation 1. So that's why I got 100. I am not writing angle 0 degree because it's the same. So after plugging that ion value, after simplifying, finally I got I2 magnitude 1, angle minus 90 degree. You just look the phasor calculation. It's just simply the calculation. And after plugging I2 into this equation, finally I got ion value 2 at an angle of 0 degree ampere. So you are done. So just what you need to write down these two equations correctly and plug in all number, and then you see how you can calculate ion I2 with the help of phasor algebra, general algebra, whatever technique you apply. That's all. Is everybody fine so far?
Yeah.
Okay, great. So now moving forward, now we'll be looking the process to determine admittance parameter. So far we discussed that is the impedance parameter. Now here it is the admittance parameters, means the Y parameters. Now everybody see, as I told you, the topmost figure, I already showed you this figure. So there is left side part A and part B. But to calculate admittance parameter, we will be considering this figure, figure B, where there are current source. So keep in mind, we consider left side figure with voltage source V1, V2 to determine impedance parameter. Now to calculate admittance parameter, you have to consider the current source. So that's why in this circuit, two-port network, there is current source ion, corresponding voltage V1. Right side, there is current source I2, corresponding voltage V2. Now, when considering this circuit, how we can write down equation relating ion V1, I2, V2 in terms of admittance. So therefore, everybody see this equation. What I am writing? Ion equal to Y1 on V1 plus Y12 V2. So if you all remember, you know that Y is the admittance and Y is the reciprocal of impedance. This means Y equal to 1 over G, because G equal to V over I and Y equal to 1 over G. That's why I equal to Y multiplied by V. That's why equation is ion equal to Y1 on into V1 plus Y12 into V2. I mean, in the similar fashion as to the impedance parameter that we showed a few slides back. Similarly, I2 equation is Y21 into V1 plus Y22 multiplied by V2. Or similarly, in matrix form, you could write I1 into I2. And then this is the Y matrix, those four parameters multiplied by V1, V2 matrix, or simply admittance matrix V1 into V2. And what does that Y1 on, Y1 to Y2 on, Y2 to refer to? Y1 on is short circuit input impedance. Y1 to is short circuit transfer impedance from port 2 to port 1. Y21 short circuit transfer admittance from port 1 to port 2. And Y22 short circuit output admittance. So you remember in the previous case, we used the word like open circuit, open circuit, open circuit always. In this case, it is the short circuit, always short circuit. This means to find out these four parameters, we have to make on port short, either right side port or left side port. Now everybody see right side diagram, first diagram. What I did, on the left side there is current source ion, there is voltage source current entering, but on the right side I have made short circuit. Because I have made short circuit, this means voltage V2 is 0. And because voltage V2 is 0, this means current is entering this time. So, and then when it is V2 0, so what you are getting? Everybody look the original equation. If you put V2 0, V2 0 in both equations, so these two terms cancels. So you are getting Y1 on equal to ion over V1. And now you see inside the network that I have written Y1 on equal to ion over V1, assuming V2 0. Similarly, Y2 on equal to I2 over V1. That is coming from equation 2. Look, Y21 equal to I2 over V1 if you put V2 0. Similarly, now see the bottom figure. In this case, I have made left side port short. This means now V1 0, ion current is entering, but on the right side there is current source I2, and hence current I2 is entering. Now, in this case, what you are doing, you are making V on 0. So now go back to the original equation. You put V on 0, V on 0. So this means these two terms cancel out. So what you will be getting? You will be getting Y12 equal to ion over V2. Y22 equal to I2 over V2. So now look inside, exactly that I am doing. So in that way, soon in next two slides, we will be discussing two numerical problems for this admittance parameters calculation. So just everybody keep in mind. So in this case, we have to make either right side or left side short circuit to get those four parameters. Everybody is fine so far? Look good?
Yep.
Okay, great. So now see the next slide, an example, two example basically. Okay, everybody see? Obtain the Y parameters for the following pi circuit. Everybody say, there are two types of circuits. One is called this pi circuit, other one is called T circuit. That looks like the letter T. So in this case, you see, it looks like the that's Roman symbol pi. That's why accordingly it is called the pi circuit. This 4 ohm, 2 ohm, 8 ohm, the way they are positions, they are making a pi circuit. And here there are input port and here there are output port. Now based on this pi circuit or diagram, we have to find out Y parameters. This means those four parameters, Y11, Y12, Y21, and Y22. Now see the solution in the next slide. So everybody see, again I have, at the beginning I have redrawn that diagram, pi circuit. Now you see what I did in the next figure, I have kept left side source. I have assumed that, okay, there is a current source ion is flowing, there is corresponding voltage V on, but you see right side I have made it short because now I am calculating the Y parameter. So I have to make right side short, or in the next case left side short. So you see right side short means V2 equal to 0, but current I2 is flowing. Now with this condition, making V2 equal to 0 or making right side short, what you will be getting? You will be getting two parameters, Y11 and Y21, according to those equation. So what was Y11? Y11 is ion over V1. Now ion is ion, there is no value. But what is V1? Look the diagram. So V1 is ion multiplied by what is the equivalent impedance based on this condition. So everybody see what's the condition? Condition is because right side is sorted, this means 8 ohm has been sorted out. So only 2 ohm and 4 ohm are remaining. So and then what is their equivalent? Just 4 ohm will be in parallel to ohm. So this means V1 is ion multiplied by parallel combination of 4 and 2. That I am showing you see on the right side. V1 equal to ion in parenthesis 4 parallel 2. And that 4 parallel 2 makes 1.33. So I have written ion multiplied by 1.33 volt. And I plugged in this number into the Y11 equation. You see ion multiplied by 1.33. So ion cancelled. You are getting on over this one 0.75 Siemens, because you are calculating admittance. So the unit is mho or Siemens. Similarly, for Y21, I2 over V1, I2 over V1. So now you have to look the diagram. So V1 is in this equation, V1 just now we calculated V1 is on 0.33 ion that I have put in the denominator, but in the numerator, you have to find out I2. So everybody see what is I2? So because this is sorted out, so this means I2 is entering through 2 ohm. Now we have to find out how much current is flowing through 2 ohm. Now you see the main current is the ion. That current is entering, something is going through 4 ohm and something is going 2 ohm. And then rest 8 ohm is sorted. So the same current is flowing through here as well. So you have to apply the current divider rule to get the current through 2 ohm. So everybody see here on the right side around middle portion, I am applying current divider rule. So I2, my goal is to find out I2, but I am finding I2 with the help of ion, because ion is the total current, because there is the current source on the left side. And that's why you see I have given minus sign, because I2 direction is opposite to the ion direction. Ion is entering going right side, but IT is flowing through the to the left side. That's why there is a minus sign. See, current divider rule, ion, total current. I have to find out current through 2 ohm. That's why I am multiplying 4 divided by 2 plus 4 is 6. So the result is minus ion multiplied by 0.6. So that I substituted into the Y21 equation. So ion cancelled. Finally, I got result minus 0.5 Siemens. Everybody, could you follow this calculation? Please try to understand. This is very important. So I am assuming everybody is understanding. Now you see, we have to find out two more parameters. You see at the bottom, Y22 and Y12. What is Y22? I2 over V2, and Y12 ion over V2. Now, when calculating these two parameters, Y22 and Y12, what's the condition? Everybody see this diagram. Now I have to make left side port short. This means now V1 has been 0. Ion current is entering, but V1 has been 0 because right side I am assuming there is a current source I2, corresponding voltage V2 and I2 current enter. Now based on this diagram, now you have to calculate Y22 and Y12. So Y22 is I2 over V2. What is I2? So I2 is I2, but what is V2? V2 is I2 multiplied by the equivalent impedance of this network, whatever it is. So, but you see, because left side port, this means 6 ohm has been sorted out. So therefore, only resistances are 2 ohm and 8 ohm. And 2 and 8, those two are in parallel. So therefore, you see right side, here the calculation I have written V2 equal to I2 multiplied by this 8 parallel 2. So an 8 parallel to that makes me 1.6. So B2 equal to 1.6 into I2. So I have plugged in this number here. I2 cancelled on over 1.6, 0.625 Siemens. Now Y12 is ion over V2. So V2 I just calculated, I plugged in the denominator, but what is ion? You see the diagram. What is ion? Ion is flowing from the opposite side. It is opposite to the I2. That's why you see on the left side I am calculating ion and I have given minus sign. But that I2 is entering through 2 ohm and something is going through 8 ohm. I need how much current is entering through 2 ohm, because that is the current that ion is entering through 2 ohm. So I am using the current divider rule here. You see, ion equal to minus I2. My goal is to find out current 2. That's why I'm multiplying by 8. and divide by 2 plus 8 is 10. So that gives me minus I2 into 0.8. So I plugged in this number here, and V2 already we know. I2 multiplied by 1.6, I2 cancelled, I got minus 0.5 Siemens. And then I am done. I got all four parameters, Y11, Y21, Y22, and Y12. So is everybody fine?
Yeah.
This is just, I mean, calculation. You need to be a little bit patient and little bit careful, because you are making sort and one resistance is getting sorted out, and then which resistance are remaining, and you are applying the current divider rule. So that's why you have to be a little bit careful in calculations, then you are fine. I mean, not difficult at all, just you have to be careful. Okay, I think I have one more problem, and then that's all for today. You see, this is the last problem for today. Obtain the Y parameters for the following T circuit. Everybody see, as I told you, the previous one was pi circuit, but this one is the T circuit. You see, it looks like the symbol T. Like you see that upper that bar and then this bar. So it looks like the letter T. Accordingly, it is called the T circuit. Now for this T circuit, you have to find out those four parameters. This means that Y parameters. Again, left side on put, right side on put. This is a two-port network. Now, in next slide, so everybody see the solutions. Again, I am redrawing that circuit, and then I want to calculate Y11, which is I1 over V1, and Y21, I2 over V1. And what should be my condition? My condition should be right side port should be shorted. I mean, the same technique that we did in the previous problem. So V2 is 0 and I2 current is entering. On the left side, I have to consider, okay, there is current source ion. Consequently, ion current is entering. Now, based on this concept, you see Y1 equal to ion over V1. So ion is ion, but what is V1? V1 is that ion that current is entering multiplied by what is the equivalent impedance here, including that 6 ohm. So ion multiplying by the whole impedance, that will be actually the V1. Now we have to find out that impedance. Now everybody see, right side this is short. So this means this is just a cable. So 18 ohm and 12 ohm are in parallel. And that parallel combination is in series with 6. So you see on the right side I have written parallel result, like 12 multiplied by 18 over 12 plus 18 is 30 plus 6 this series. So the equivalent impedance here is 13.2 ohm. So that's why now come back to the equation, Y1 equal to ion over for V on 13.2 ion. Ion cancelled. This is Siemens, but I have put the result is millisiemens, 75.75 millisiemens. Similarly, Y21 is I2 over V1. Again, for the same circuit. Now, you know V1, we just calculated 13.2 into ion. But what is I2? Everybody see, from this circuit, you have to find out I2. And I2 is opposite to I1. So this means that you have to find out current flowing through 18 ohm. Now, ion current is entering at this node and it is divided into two parts. Something is going through 12 and some portion is going through 18. Now you have to apply the current divider rule here. Therefore, everybody see my calculation around the middle portion I2 minus. I have put minus sign because I2 is opposite in direction with the ion. So minus ion, and I am applying the current divider rule here. So I have to multiply it by 12, and in the denominator 12 plus 18 is 30. So I got I2 minus 0.4 into ion. and I substituted that value into the Y2 equation. Finally, I got minus 30.3 millisiemens. I mean, the previous result is in Siemens, but this I converted into millisiemens. Now you have to find out two other parameters, which is Y22 and Y12. And what should be the condition? Condition should be you have to make left side port short circuited. This means V1 is 0, ion is entering. Right side I have assumed there is current source, there is voltage V2 and current I2. Now based on this diagram, you have to find out Y22, which is I2 over V2. So I2 is I2. What is V2? V2 means I2 multiplied by the parallel combination of this. I mean, similar to the previous diagram. So this means 6 and 12 are in parallel, and then that combination is in series with 18. So you see on the right side, I have calculated 6 parallel 12 and plus 18. So finally, I got 22 ohm. That is the equivalent impedance value. So that's why now see the equation Y22, I2 over V2. For V2, I am substituting that 22 multiplied by I2. So I2 cancelled. Finally, I got 45.45 millisiemens. Now, see Y12 equal to ion over V2. So again, V2 is that 22 multiplied by I2. But what is ion? You see, ion is opposite in direction of I2. So ion is flowing through the 6 ohm. You have to find out the current flowing through the 6 ohm. Now again, you see, in the left side, I have calculated ion minus I2. Again, I am applying the current divider rule. That I2 is entering at this point, at this node, and it is divided into two components. Something is going through 12 and something is going through 6 ohm. You need to know how much is flowing through 6 ohm. So ion equal to minus I2 total current multiplied by 12, and in the denominator 12 plus 6 is 18. So finally you are getting ion equal to minus I2 multiplied by 0.667. This number you plug in here in Y2 equation. Finally you are getting minus 30.3 millisiemens. And that's all. You calculated all those four parameters, Y1 and Y21, Y12 and Y22. So everybody understands the calculation? Do you have any questions, confusion?
Not at all. It all looks good. I mean, it all makes perfect sense.
Yeah. I mean, as I told you, just simple like circuit calculation. After the class, once again, you take your pen and paper and open these slides and you calculate, then you will be fine. Just you have to be a little bit patient and careful, but simply the circuit. If you make mistake in any series parallel combination or what, then you will get completely wrong result. Otherwise, you will be fine. So therefore, I would recommend you all again try to understand from the first slide, and that how you are calculating impedance parameters, in this case admittance parameter, and look all the example, understands, and then you jump into the homework. So now I believe you all are ready to solve all those 5 problems as given in the homework file. Okay, then so with that, today we are done with the two-port network. So from next class, I will be starting Fourier series application in circuit analysis techniques. And then finally the three-phase circuit. Now we are almost 80% of the syllabus are done. Now we just have remaining 20% or even less than 20%. I think 50% is remaining, 15%. 2 class will be about Fourier series, and then another 2 class will be about three-phase circuit, and then some other discussion of your homework and exam, etc. Then we will be done. Okay, so now I am stop sharing. Just a moment. Okay, now can you see me?
Yep, sure can.
Okay, okay, everybody. So here is the end today. So have a good day, and everybody, please be safe, and see you on Friday.
All right, sounds good. Thank you, Dr. Ali.
Okay, so everybody, then bye. I am closing the meeting. Okay, Jesse Barnes. Okay, everybody, he's saying okay. Thanks, doctor. Have a good day. Okay, thanks, Jesse Barnes and everybody. Okay, bye.